A 60 kilogram acrobat hangs motionless from two light, strong ropes attached to a roof. And we have to determine the tensions T1 and T2 in those ropes. Now, the first thing you do is draw a force diagram for the acrobat. Use a dot and use dotted lines for your diagrammed axes. So, first of all, the first force acting on the acrobat must be her weight, and that's acting straight down the way, and it's W. W, the weight, we know is equal to mg, and we know the mass of the acrobat, so with a little bit of calculation, we can certainly work out the weight of the acrobat. She has a weight of 588 newtons. Now comes the tricky part. Draw in the other forces. So we've got T1, the force acting there, and we've got T2, the force acting there like that. Now, if the acrobat is motionless, then the vertical components of T1 and T2 must add up to give you the weight. So here's the vertical component of T1, and there's a vertical component of the tension T2. And those two vertical forces must add up to give you the weight. So if we place them like that, remember we can move vectors about, you can see that the two vertical components of the tensions must add up to give you the weight. And that simply means that the vertical component of the tension must be equal to half the weight. Now let's do a little diagram of one of the tensions here like that. And there we have it. We have tension T1. We have it at an angle of 30 degrees to the vertical. And there is the vertical component, 294 newtons, which must be half the weight. So now we've got a little calculation to do then. So we can go over and do the calculation as follows. Cos 30 degrees of this triangle here is going to equal to the adjacent divided by the hypotenuse. 294 is the adjacent if you're dealing with cos 30, and the hypotenuse is T1. So we've got cos 30 degrees equals 294 over T1. So if we rearrange that, we have T1 equals 294 times cos 30, and therefore the tension T1 is 255. And that also must mean that tension T2 is going to be 255 as well, because both tensions will be the same. So that's how we do the famous hanging acrobat problem. Resolve the two vertical components of the tensions and realise that those two vertical component of the tensions added up must give you the value for the weight force acting downwards. And then we can go to one simple triangle and solve it with trigonometry to get our answers for the tension.